Okay, so moving on to our next chapter, getting started with LangChain. In this chapter, we're going to be introducing LangChain by building a simple LLM-powered assistant that will do various things for us. It will be multimodal, generating some text, generating images, generate some structured outputs. It will do a few things. Now, to get started, we will go over to the course repo. All of the code, all the chapters are in here. There are two ways of running this, either locally or in Google Colab. We would recommend running in Google Colab because it's just a lot simpler with environments, but you can also run it locally. And actually for the capstone, we will be running it locally. There's no way of us doing that in Colab. So if you would like to run everything locally, I'll show you how quickly now. If you would like to run in Colab, which I would recommend at least for the first notebook chapters, just skip ahead. There will be chapter points in the timeline of the video. So for running it locally, we just come down to here. So this actually tells you everything that you need. So you will need to install UV. Right, so this is the package manager that we recommend by the Python and package management library. You don't need to use UV, it's up to you. UV is very simple, it works really well. So I would recommend that. So you would install it with this command here. This is on Mac, so it will be different otherwise. If you are on Windows or otherwise, you can look at the installation guide there and it'll tell you what to do. And so before we actually do this, what I will do is go ahead and just clone this repo. So we'll come into here. I'm going to create like a temp directory for me because I already have the LangChain course in there. And what I'm going to do is just git clone LangChain course. Okay. So you will also need to install Git if you don't have that. Okay. So we have that. Then what we'll do is copy this. Okay, so this will install Python 3.12.7 for us with this command. Then this will create a new venv within that or using Python 3.12.7 that we've installed. And then UV sync will actually be looking at the pyproject.toml file. That's like the package installation for the repo and using that to install everything that we need. Now, we should actually make sure that we are within the LangChain course directory. And then yes, we can run those three. And there we go. So everything should install with that. Now, if you are in Cursor, you can just do cursor dot, or we can run code dot. If in VS Code, I'll just be running this. And then I've opened up the course. Now, within that course, you have your notebooks, and then you just run through these, making sure you select your kernel, Python environment, and making sure you're using the correct venv from here. So that should pop up already as this venv bin Python, and you'll click that, and then you can run through. When you are running locally, don't run these. You don't need to. You've already installed everything. So you don't, this specifically is for Colab. So that is running things locally. Now let's have a look at running things in Colab. So for running everything in Colab, we have our notebooks in here. We click through, and then we have each of the chapters through here. So starting with the first chapter, the introduction, which is where we are now. So what you can do to open this in Colab is either just click this Colab button here, or if you really want to, for example, maybe this is not loading for you, what you can do is you can copy the URL at the top here. You can go over to Colab, you can go to Open, GitHub, and then just paste that in there and press Enter. And there we go. We have our notebook. Okay, so we're in now. What we will do first is just install the prerequisites. So we have LangChain, just a load of LangChain packages here. LangChain Core, LangChain OpenAI, because we're using OpenAI, and LangChain Community, which is needed for running what we're running. Okay, so that has installed everything for us. So we can move on to our first step, which is initializing our LLM. So we're going to be using GPT-4o Mini which is slightly small but fast, but also cheaper model. That is also very good from OpenAI. So what we need to do here is get an API key. Okay, so for getting that API key, we're going to go to OpenAI's website, and you can see here that we're opening platform.openai.com, and then we're going to go into settings, organization, API keys. So you can copy that or just click it from here. Okay, so I'm going to go ahead and create a new secret key. Actually, just in case you're kind of looking for where this is, it's settings, organization, API keys again. Okay, create a new API key. I'm going to call it LangChain course. I'll just put it under semantic router. That's just my organization. You put it wherever you want it to be. And then you would copy your API key. You can see mine here. I'm obviously going to revert that before you see this, but you can try and use it if you really like. So I'm going to copy that, and I'm going to place it into this little box here. You could also just place it, put your full API key in here. It's up to you, but this little box just makes things easier. Now, what we've basically done there is just pass in our API key. We're setting our OpenAI model, GPT-4o mini. And what we're going to be doing now is essentially just connecting and setting up our LLM parameters with LangChain. So we run that. We say, okay, we're using a GPT-4o mini. And we're also setting ourselves up to use two different LLMs here, or two of the same LLM with slightly different settings. So the first of those is an LLM with a temperature setting of 0. The temperature setting basically controls almost the randomness of the output of your LLM. And the way that it works is when an LLM is predicting the sort of next token or next word in a sequence, it'll provide a probability actually for all of the tokens within the LLM's knowledge base, or what the LLM has been trained on. So what we do when we set a temperature of 0 is we say, you are going to give us the token with highest probability according to you, okay? Whereas when we set a temperature of 0.9, what we're saying is, okay, there's actually an increased probability of you giving us a token that, according to your generated output, is not the token with the highest probability according to the LLM. But what that tends to do is give us more sort of creative outputs. So that's what the temperature does. So we are creating a normal LLM and then a more creative LLM with this. So what are we going to be building? We're going to be taking a article draft. So like a draft article from the Aurelio learning page. And we're going to be using LangChain to generate various things that we might find helpful as we have this article draft and we're editing it and just kind of like finalizing it. So what are those going to be? You can see them here. We have the title for the article, the description, an SEO friendly description specifically. The third one, we're going to be getting the LLM to provide us advice on an existing paragraph and essentially writing a new paragraph for us from that existing paragraph. And what it's going to do, this is the structured output part, is it's going to write a new version of that paragraph for us, and it's going to give us advice on where we can improve our writing. Then we're going to generate a thumbnail or hero image for our article. So nice image that you would put at the top. So here, we're just going to input our article. You can put something else in here if you like. Essentially, this is just a big article that's written a little while back on agents. And now we can go ahead and start preparing our prompts, which are essentially the instructions for our LLM. So LangChain comes with a lot of different like utilities for prompts, and we're going to dive into them in a lot more detail, but I do want to just give you the essentials now, just so you can understand what we're looking at least conceptually. So prompts for chat agents are at a minimum broken up into 3 components. Those are the system prompt. This provides instructions to our LM on how it should behave, what its objective is, and how it should go about achieving that objective. Generally, system prompts are going to be a bit longer than what we have here depending on the use case. Then we have our user prompts. So these are user written messages. Usually, sometimes we might want to pre-populate those if we want to encourage a particular type of conversational patterns from our agent. But for the most part, yes, these are going to be user generated. Then we have our AI prompts. So these are, of course, AI generated. And again, in some cases, we might want to generate those ourselves beforehand or within a conversation if we have a particular reason for doing so. But for the most part, you can assume that these are actually user and AI generated. Now, LangChain provides us with templates for each one of these prompt types. Let's go ahead and have a look at what these look like within LangChain. So to begin, we are looking at this one. So we have our system message prompt template and human message, which is the user that we saw before. So we have these two. System prompt, keeping it quite simple here. You are an AI system that helps generate article titles, right? So our first component where we want to generate is article title. So we're telling the AI, that's what we want it to do. And then here, right? So here we're actually providing kind of like a template for a user input. So yes, as I mentioned, user input can be, it can be fully generated by a user. It might be kind of not generated by a user. It might be setting up a conversation beforehand, which then a user would later use. Or in this scenario, we're actually creating a template, and what the user will provide us will actually just be inserted here inside article. And that's why we have this import variables. So what this is going to do is, okay, we have all of these instructions around here. They're all going to be provided to OpenAI as if it is the user saying this. But it will actually just be this here that a user will be providing. Okay. And we might want to also format this a little nicer. It kind of depends. This will work as it is, but we can also put something like this to make it a little bit clearer to the LLM. Okay, what is the article? Where are the prompts? So we have that. And you can see in this scenario, there's not that much difference between what the system prompt and the user prompt is doing. And it's a particular scenario. It varies. When you get into the more conversational stuff, as we will do later, you'll see that the user prompt is generally more fully user generated or mostly user generated. And much of these types of instructions we might actually be putting into the system prompt. It varies, and we'll see throughout the course many different ways of using these different types of prompts in various different places. Then you'll see here, so I just want to show you how this is working. We can use this format method on our user prompt here to actually insert something within the article input here. So we're going to go user prompt format, and then we pass in something for article. Okay. And we can also maybe format this a little nicer, but I'll just show you this for now. So we have our human message, and then inside the content, this is the text that we had. All right, you can see that we have all of this, right? And this is what we wrote before. We wrote all this except from this part. We didn't write this. Instead of this, we had article. All right. So let's format this a little nicer so we can see. Okay. So this is exactly what we wrote up here. Exactly the same, except from now we have test string instead of article. So later, when we insert our article, it's going to go inside there. That's all it's doing. It's like it's an F string in Python. Okay. And this is one of the things where people might complain about LangChain. This sort of thing can be, it seems excessive because you could just do this with an F string. But there are, as we'll see later, particularly when you're streaming, there's really helpful features that come with using LangChain's kind of built-in prompt templates, or at least message objects that we'll see. So, we need to keep that in mind. Again, as things get more complicated, LangChain can be a bit more useful. So, chat prompt template. This is basically just going to take what we have here, our system prompt, user prompts. You could also include some AI prompts in there. And what it's going to do is merge both of those. And then when we do format, what it's going to do is put both of those together into a chat history. Okay, so let's see what that looks like first in a more messy way. Okay, so you can see we have just the content, right? So it doesn't include the whole, before we had human message, we're not seeing anything like that here. Instead, we're just seeing the string. So now let's switch back to print. And we can see that what we have is our system message here. It's just prefixed with this system. And then we have human, and it's prefixed by human, and then it continues, right? So that's all it's doing. It's just kind of merging those in some sort of chat log. We could also put in like AI messages, and they would appear in there as well. Okay, so we have that. Now that is our prompt template. Let's put that together with an LLM to create what would be in past LangChain be called an LLM chain. Now we wouldn't necessarily call it an LLM chain because we're not using the LLM chain abstraction. It's not super important if that doesn't make sense. We'll go into it in more detail later, particularly in the LCEL chapter. So what this chain will do, think LangChain is just chains where we're chaining together these multiple components. It will perform the steps prompt formatting. So that's what I just showed you. LLM generation, so sending our prompt to OpenAI, getting a response, and getting that output. So you can also add another step here if you want to format that in a particular way. We're going to be outputting that in a particular format so that we can feed it into the next step more easily. But there are also things called output parsers, which parse your output in a more dynamic or complicated way, depending on what you're doing. So this is our first look at LCEL. I don't want us to focus too much on the syntax here because we will be doing that later, but I do want you to just understand what is actually happening here and logically what are we writing. So all we really need to know right now is we define our inputs with the first dictionary segment here. All right, so this is our inputs, which we have defined already. Okay, so if we come up to our user prompt here, we said the input variable is our article, right? And we might have also added input variables to the system prompt here as well. In that case, let's say we had you're an AI assistant called name, right? That helps generate article titles. In this scenario, we might have an input variables name here, right? And then what we would have to do down here is we would also have to pass that in, right? So we would have article, but we would also have name. So basically, we just need to make sure that in here, we're including the variables that we have defined as input variables for our first prompts. Okay, so we can actually go ahead and let's add that so we can see it's in action. So we'll run this again and just include that or reinitialize our first prompt. So we see that. And if we just have a look at what that means for this format function here, it means we'll also need to pass in a name. Okay, and call it Joe. Okay, so Joe the AI, right? So you are an AI assistant called Joe now. Okay, so we have Joe, our AI, that is going to be fed in through these input variables. Then we have this pipe operator. The pipe operator is basically saying whatever is to the left of the pipe operator, which in this case would be this, is going to go into whatever is on the right of the pipe operator. It's that simple. Again, we'll dive into this and kind of break it apart in the LCEL chapter, but for now, that's all we need to know. So this is going to go into our first prompt. That is going to format everything. It's going to add the name and the article that we provided into our first prompt. And then it's going to output that, right? It's going to output that. We have our pipe operator here. So the output of this is going to go into the input of our next step. It's our creative LLM. Then that is going to generate some tokens. It's going to generate our output. That output is going to be an AI message. And as you saw before, if I take this bit out, within those message objects, we have this content field, okay? So we are actually going to extract the content field out from our AI message to just get the content. And that is what we do here. So we get the AI message out from our LLM, and then we're extracting the content from that AI message object, and we're going to passing it into a dictionary that just contains article title, like so. Okay, we don't need to do that. We can just get the AI message directly. I just want to show you how we are using this sort of chain in LCEL. So once we have set up our chain, we then call it or execute it using the invoke method. Into that, we will need to pass in those variables. So we have our article already, but we also gave our AI a name now. So let's add that and we'll run this. Okay, so Joe has generated us a article title, Unlocking the Future, the Rise of Neurosymbolic AI Agents. Cool, much better name than what I gave that article, which was AI Agents are Neurosymbolic Systems. No, I don't think I did too bad. Okay, so we have that. Now, let's continue, and what we're going to be doing is building more of these types of LLM chain pipelines where we're feeding in some prompts, we're generating something, getting something, and doing something with it. So, as mentioned, we have the title. We're now moving on to the description. So we're going to generate a description. So we have our human message prompt template. So this is actually going to go into a similar format as before. We probably also want to redefine this because I think I'm using the same system message there. So let's go ahead and modify that. Or what we could also do is let's just remove the name now because I've shown you that. So what we could do is you're an AI assistant that helps build good articles, right? Build good articles. And we could just use this as our, generic system prompt now. So let's say that's our new system prompt. Now we have our user prompt. You're tasked with creating a description for the article. The article is here for you to examine. Here is the article title. Okay, so we need the article title now as well in our input variables. And then we're going to output an SEO-friendly article description. And we're just saying, just to be certain here, do not output anything other than the description. So, sometimes an LLM might say, hey, look, this is what I've generated for you. The reason I think this is good is because so on and so on and so on, right? If you're programmatically taking some output from an LLM, you don't want all of that fluff around what the LLM has generated. You just want exactly what you've asked it for, okay? Because otherwise you need to parse out with code and it can get messy and also just far less reliable. So we're just saying, don't output anything else. Then we're putting all of these together. So system prompt and the second user prompt, this one here. We're putting those together into a new chat prompt template. And then we're going to feed all of that in to another LCEL chain as we have here to generate our description. So let's go ahead. We invoke that as before. We're just making sure we add in the article title that we got from before. And let's see what we get. Okay, so we have this. Explore the transformative potential of neurosymbolic AI agents in a little bit long, to be honest. But yeah, you can see what it's doing here, right? And of course, we could then go in, we see this is kind of too long. We're like, SEO-friendly description, not really. So we can modify this. Output the SEO-friendly description. Make sure we don't exceed, let me put that in a new line. Make sure we don't exceed, say, 200 characters, or maybe it's even less for SEO. I don't have a clue. I'll just say 120 characters. I do not output anything other than the description, right? So we could just, go back, modify our prompting, see what that generates again. Okay, so much shorter, probably too short now, but that's fine. Cool, so we have that, we have a summary, process that, and that's now, in this dictionary format that we have here. Cool. Now, the third step, we want to consume that first article variable with our full article. And we're going to generate a few different output fields. So for this, we're going to be using the structured output feature. So let's scroll down. We'll see what that is or what that looks like. So structured output is essentially we're forcing the LLM, like it has to output a dictionary with these, particular fields. Okay. And we can modify this quite a bit, but in this scenario, what I want to do is I want there to be an original paragraph, right? So I just want it to regenerate the original paragraph because I'm lazy and I don't want to extract it out. Then I want to get the new edited paragraph. This is the LLM generated improved paragraph. And then we want to get some feedback because we don't want to just automate ourselves. We want to augment ourselves and get better with AI rather than just being like, you do this. So that's what we do here. And you can see that here we're using this Pydantic object. And what Pydantic allows us to do is define these particular fields, and it also allows us to assign these descriptions to a field. And LangChain is actually going to go ahead, read all of this, right? Even reads, so for example, we could put integer here, and we could actually get a numeric score for our paragraph, right? And we can try that, right? So let's just try that quickly. I'll show you. So numeric score. In fact, let's even just ignore. Let's not put anything here. So I'm going to put constructive feedback on the original paragraph, but I just put int here. So let's see what happens. Okay. So we have that. And what I'm going to do is I'm going to get our creative LLM. I'm going to use this with structured output method. And that's actually going to modify that LLM class, create a new LLM class that forces that LLM to use this structure for the output, right? So passing in paragraph into here. Using this, we're creating this new structured LLM. So let's run that and see what happens. Okay, so we're going to modify our chain accordingly. Maybe what I can do is also just remove this bit for now, so we can just see what the structured LLM outputs directly. And let's see. Okay, so now you can see that we actually have that paragraph object, right? The one we defined up here, which is kind of cool. And then in there, we have the original paragraph, right? So this is where this is coming from. I definitely remember writing something that looks a lot like that. So I think that is correct. We have the edited paragraph. So this is, okay, what it thinks is better. And then interestingly, the feedback is 3, which is weird, right? Because here we said the constructive feedback on the original paragraph. But what we're doing when we use this with structured output, or what LangChain is doing, is essentially performing a tool call to OpenAI. And what a tool call can do is force a particular structure in the output of an LLM. So when we say feedback has to be an integer, no matter what we put here, it's going to give us an integer. Because how do you provide constructive feedback with an integer? It doesn't really make sense. But because we've set that limitation, that restriction here, that is what it does. It just gives us the numeric value. So I'm going to shift that to string, and then let's rerun this, see what we get. Okay, we should now see that we actually do get constructive feedback. All right, so yeah, we can see it's quite long. So the original paragraph effectively communicates the limitations of neural AI systems in performing certain tasks. However, it could benefit from slightly improved clarity and conciseness. For example, the phrase "was becoming clear" can be made more direct by changing it to "became evident." Well, yeah, true. Thank you very much. So yeah, now we actually get that feedback, which is pretty nice. Now let's add in this final step to our chain. Okay, and it's just going to pull out our paragraph object here and extracting to a dictionary. We don't necessarily need to do this. Honestly, I actually kind of prefer it within this paragraph object, but just so we can see how we would parse things on the other side of the chain. Okay, so now we can see we've extracted that out. Cool, so we have all of that. Interesting feedback again, but let's leave it there for the text part of this. Now let's have a look at the sort of multimodal features that we can work with. So this is, maybe one of those things that's kind of seems a bit more abstracted, a little bit complicated, where it maybe could be improved, but we're not going to really be focusing too much on the multimodal stuff. We'll instead be focusing on language, but I did want to just show you very quickly. So we want this article to look better. Okay, we want to generate a prompt based on the article itself that we can then pass to DALL-E, the image generation model from OpenAI, that will then generate an image, like a thumbnail image for us. Okay, so the first step of that is we're actually going to get an LLM to generate that. All right, so we have our prompt that we're going to use for that. So I'm going to say generate a prompt with less than 500 characters to generate an image based on the following article. Okay, so that's our prompt. Yeah, super simple. We're using the generic prompt template here. You can use that. You can use user prompt template. It's up to you. This is just like the generic prompt template. Then what we're going to be doing is, based on what this outputs, we're then going to feed that in to this generate and display image function via the image prompt parameter. That is going to use the DALL-E API wrapper from LangChain. It's going to run that image prompt, and we're going to get a URL out from that, essentially. And then we're going to read that using SK image here. Right, so we're just going to read that image URL, going to get the image data, and then we're just going to display it. Okay, so pretty straightforward. Now, again, this is a LCEL thing here that we're doing, and we have this runnable lambda thing. When we're running functions within LCEL, we need to wrap them within this runnable lambda. I don't want to go too much into what this is doing here because we do cover it in the LCEL chapter. But it's just, all you really need to know is we have a custom function, wrap it in runnable lambda, and then what we get from that, we can use within this here, right? The LCEL syntax. So what are we doing here? Let's figure this out. We are taking our original, that image prompt that we defined just up here, right? Input variable to that is article, okay? We have our article data being input here, feeding that into our prompt. From there, we get our message that we then feed into our LLM. From the LLM, it's going to generate us an image prompt, like a prompt for generating our image for this article. We can even, let's print that out so that we can see what it generates, because I'm also kind of curious. Okay, so we'll just run that, and then let's see. It will feed in that content into our runnable, which is basically this function here. And we'll see what it generates. Okay. Don't expect anything amazing from DALL-E. It's not the best, to be honest, but at least we see how to use it. Okay, so we can see the prompt that was used here. Create an image that visually represents the concept of neurosymbolic agents, depict a futuristic interface where large language model interacts with traditional code, symbolizing integration of, oh my gosh, something computation, include elements like a brain to represent neural networks, gears or circuits or symbolic logic, and a web of connections illustrating vast use cases of AI agents. Oh my gosh, look at all that. Big prompt. Then we get this. So, DALL-E is interesting, I would say. We could even take this. Let's just see what that comes up with in something like Midjourney. You can see these way cooler images that we get from just another image generation model. Far better, but pretty cool, honestly. So in terms of generation, images, the phrasing, the prompt itself is actually pretty good. The image, it could be better, but that's it, right? So with all of that, we've seen a little introduction to what we might be building with LangChain. So that's it for our introduction chapter. As I mentioned, we don't want to go too much into what each of these things is doing. I just really want to focus on, okay, this is kind of how we're building something with LangChain. This is the overall flow, but we don't really want to be focusing too much on, okay, what exactly LCEL is doing, or what exactly this prompt thing is that we're setting up. We're going to be focusing much more on all of those things and much more in the upcoming chapters. So for now, we've just seen a little bit of what we can build before diving in more detail.